Hey everyone, welcome back to the channel Code with AKJ. Today is day 45 of solving Geeks for Geeks problem of the day. And today's question is delete alternate nodes. So the question says here, given a singly linked list, delete all alternate nodes of the list. That is, delete all the nodes present in even positions. So given two examples. The first example says here, the linked list contains 1, 2, 3, 4, 5, 6. And we need to delete the nodes which are present in even position. That is, the nodes 2 and 4. So after deleting these alternating nodes, our resultant linked list would be 1, 3 and 5. Same goes with second example. The nodes which are present in even positions are 59 and 20. So after deleting these nodes, our resultant linked list would be 99 and 42. So they are expecting us to finish this problem in O of n time complexity, and space complexity should be O of 1. So what our initial thoughts would be that to take a count variable and just keep a track of the even portions, and if we find any even portion, we'll try to skip that element or we'll delete that particular current node, and we'll connect these links to handle these nodes which are being deleted. So let's try to come up with this approach. So let me write here the linked list 1, 2, 3, 4, 5. So let's take count variable which would be initial. We'll take two pointers here. One would be current and one would be previous. Current will point to a head pointer and previous would be null initially. So what we'll do here is we'll try to skip that particular link when the count variable becomes even. So initially, since it is 1, we'll try to move these pointers to the next node. So we'll move these pointers in such a way that first we'll move previous to the current node from here to here, and we'll move the current node to the next node from here to here. And after performing these steps, we'll increment our count to 2. So since now the count is even, we'll try to skip the current node or try to delete the current node. The positions would be here after the first step. So we need to remove this particular node from the linked list, and we need to handle these links properly. So the steps here would be to connect this particular link from 1 to 3. So our task here would be to connect from 1 to 3. So we can achieve this particular step by using these steps. That is, we'll connect previous next with the current next. This would be our first step. Through this step, the link would be changed from 1 to 3. And next step here would be to delete the current pointer using the delete function. So 2 will be eliminated from this linked list, and we need to point our current node for the next linked list processing. So our current pointer would be previous next, which is 3. So C moves from 2 to 3. So our next linked list would be something like this, where previous is pointing to 1 and current is pointing to 3. And now our counter would be 3. So since it is odd, we'll try to move our pointers using this step by moving P to C and C to the next current next, and incrementing our count to 4. Now since count is even, we'll try to delete our current pointer by interchanging these links and deleting the current node. We can change this interlinking node by using this step, that is previous next would be equal to the current next. In this way, the 3's next would be pointing to the 5, and our next step would be to delete the current node, which would be deleting this 4 node. And now we'll move our current pointer to the previous next, which is from 4 to 5. So again, our linked list would look something like this, where P is pointing to 3, C is pointing to C. And since current node is not null, we'll again do this step. We'll increment our count to 5. Since it is odd, we'll move this pointer to the next node. So P moves to 5 and C moves to the null. So since current is null, we'll stop our iteration and we'll return our previous pointer. So this would be our initial thought and the approach we would take using a count variable. And in this way, we'll try to delete all those alternating nodes present at the event position. So here, the time complexity would be O of n, as we are iterating over the linked list just for once, and space complexity would be O of 1. So this is the optimal approach we can think for this particular problem. And let's move on to the code. So let's try to code this. The base case here would be if head is null, we need to return. And since it is void function, we don't need to return anything at the last. We just need to modify this particular linked list. So let's take a count variable, which would be initially 1. We'll take 2 pointers. Current, which would be pointing to head, and previous, which would be pointing to null. And we'll iterate over this linked list until or unless current is pointing to null. Our first step would be if the count becomes even, we'll do one step, or else we'll try to move the pointers. So after finishing these two steps, we'll try to increment our counter. So if the count variable is even, we'll try to interchange the link using this step where previous next is pointing to current next. We'll try to delete the current node and we'll try to adjust our current pointer to previous next. And if it is not even, we'll try to move this pointer to the next node for further processing. So in this way, we try to modify this particular linked list in O of n time complexity, and space complexity is O of 1. So let's try to compile and run this. So let's submit. As you can see, this problem got accepted successfully. And that's it. We have successfully solved this problem of deleting alternate nodes from a single linked list. And if you found this explanation helpful, don't forget to like this video, comment down below, subscribe to my channel, and hit that bell icon for more such coding tutorials. And let me know in the comments if there are any other problems you'd like me to cover. Thanks for watching. I'll see you in the next one.